Okay, so here's a quick lesson on sex-linked traits. And so what I want to make sure that y'all understand is that the sex-linked chromosomes are on the 23rd pair. And on the 23rd pair, you either have two X's or you have an X and a Y. So if you have two X chromosomes, you are female. And if you have an X and a Y, you are male. So the sex-linked traits that we are going to discuss are always considered recessive, and they're carried on the X chromosome. So I want you to think about this logic. Females have two X chromosomes, males only have one. So for a female to inherit a recessive trait, then she would have to have a genotype, for example, say little a, for her to have the recessive trait. A male, on the other hand, only has one X chromosome, so all he has to inherit is one little a, and he has that recessive trait. So this is why it's more common for males to carry these sex-linked recessive traits, because they only have one X chromosome. So all they have to inherit is one little letter, where females have to inherit two. So that's why it's more common. So if we look at some of these Punnett squares here for sex-linked traits, the first thing is that because they are carried on the 23rd pair of chromosomes, you want to make sure you always set up with your two X's here to show the female parent and then an X and a Y for the male. And just like codominant alleles, you're going to be using superscript or exponent letters to represent that particular trait. So in this problem, in fruit flies, the gene for white eyes is sex-linked recessive. Big R would be red eyes, little r is white. Cross a white-eyed female with a normal red-eyed male. So if the female has white eyes, then because she has two X chromosomes, that's going to be two little r's. So hers is going to be X little r, X little r. The male is red-eyed, so he has the dominant, so he is a big R here. You never put any traits on the Y chromosome because those are not sex-linked traits. Only the X chromosome are sex-linked. So the Y will never carry that. So if we do our Punnett square like normal, we come down and over. So X big R, X little r, X big R, X little r, X little r y, X little r y. So this is showing you the possibility of the genotypes of siblings, okay, or offspring in general. Every single time in in this scenario, these fruit flies have one offspring. These are the chances. There's a 50% chance of it being female and a 50% chance of it being male. So be careful with the questions here. What percent of males? So that means that we're just looking at the males, which would be these two, have red eyes. So notice this is little r and this is little r. So the red-eyed trait is dominant. So that means that neither one of these have red eyes. So that's 0. White eyes, well, both of these males carry the recessive allele for white eyes. So that is both males, which is 100%. What percent of females have red eyes versus white eyes? Now we're just looking at this side of the Punnett square. So for females, they both carry a big R. So just like normal traits, if you have one capital letter, you're going to follow the dominant trait. So 100% red eyes, 0 white. Total percent of all the offspring. So we're looking at all 4 here have white eyes. So we have red, red, white, white, 50%. This side, what percent are carriers? Now, a carrier means that you have the recessive allele, you're carrying it in your genotype, but it is not expressed. So the only organisms that can be carriers are females. A male, if it has the allele, it has it. It's not a carrier. The definition of a carrier is that you have the allele, you can pass it on, but you yourself don't have the trait. So both of these females are carriers. So in this question, of the total offspring, it would be 50%, which would be 2 out of 4. For this one, same information, heterozygous, red-eyed female with a red-eyed male. So here's our female, XX, and if she's heterozygous, she's big R, little r. Red-eyed male, so he's got the dominant trait, X big R, Y. You complete your Punnett square. These were the genotypes of the parents. What fraction of all children have red eyes? So the big R, that's red eyes, red eyes, red eyes. 75%. What fraction have white? It's white, 25%. What fraction of female children carry the trait? Just look at the females. She is not a carrier, but she is. That's 1 out of 2, 50%. In humans, hemophilia is sex-linked recessive. You have a female who's a carrier, so that means she doesn't have it, but she carries the trait. That's why she's big H, little h. And a male who's normal, so he's big H. He doesn't have the recessive hemophilia trait. We complete our Punnett square. What fraction of female children have hemophilia? None of them do, because they both have at least one dominant. What fraction of female children are carriers? This one's a carrier, so 1 out of 2. What fraction of male children are normal? This male is normal. This male is not. 1 out of 2. Fraction of male children that will be carriers. Trick question. Males cannot be carriers because they either have it or they don't. What fraction of male children have hemophilia? This one has hemophilia. It contains the recessive trait. 1 out of 2, 50%.